Hi all, welcome to ugcnet. In our previous video, we have seen what's left recursion and how to eliminate left recursion from a given grammar. And in this video, we will be going through the topic left factoring. What is left factoring and how we can eliminate the left factors from a given production. So what is left factor? A given grammar contains left factor if it is of the form A produces alpha beta 1 or alpha beta 2 or etc. alpha beta n or gamma. So if a production is having this format, then we say that this production contains left factors. I will explain you what is left factor. First, just understand that if any production is of this form, then we say that it contains left factor. And in order to eliminate left factor from that, we have to convert this production to these two productions. That is, A produces alpha A dash bar gamma, A dash produces beta 1 bar beta 2 bar etc. up to beta n. So now, what do you mean by this production? The first production, it means that in a given production, here we can see that there are many terms. This is one term, this is second term, and this is nth term, and this is n plus 1th term, right? So in this type of production, if two or more terms start with the same prefix, that means if any of the two or more terms have a common prefix, then we call that grammar contains a left factor. Here you can see that the first term, second term, all these starts with the same common factor alpha. And what is this alpha? Alpha can be any combination of terminals as well as non-terminals. It can be a mix of terminals and non-terminals, or it can be only terminals, it can be only non-terminals as well. Okay, so alpha as well as beta, alpha, beta, gamma, all these are just combinations of terminals and non-terminals. For example, let us consider this production. S produces IETS bar, IETSES bar A. So here we can see that here there are three terms, right? Among these three terms, the first two terms start with the same common factor. The same common factor is IETS. So this much portion is same in these two terms, right? So this is our alpha. What comes common in the terms, that common term is our alpha. And whatever combination of terminals and non-terminals that comes after alpha in each term, whatever comes after alpha is our beta. So in this first term, there is only alpha, there is no beta, right? So our beta will be epsilon. Beta here, beta will be epsilon. Okay? And in the second term, alpha is IETS, right? So what comes after that? In the second terms, what comes after that is ES, right? So ES is our beta. And here in this third term doesn't start with IETS. That means the third term doesn't have anything common with the other two terms. So we can consider this as our gamma. And this gamma is an optional case. The production may or may not have gamma. So if there is gamma, we can consider gamma as that terminal or non-terminal, whatever it is. And if there is no gamma, remember one thing, if there is no gamma, we should not consider gamma as epsilon. Okay, we just ignore the term gamma. Okay, so this is what we call left factor. And in order to remove this left factor from this production, what we have to do? We have to convert the production into this form. Right? So what is the form? A produces alpha A dash bar gamma. And what is our alpha? In our example, alpha is IETS. Okay, and instead of A, here the grammar production is, or the grammar symbol is A. A is our starting symbol. But in our example, instead of A, we have taken S. Okay, so we can write it as S produces alpha S dash. Instead of A dash, we can write it as alpha S dash, because here in our example, our symbol is S. Okay, so alpha S dash bar gamma. So how we can write it? Instead of alpha, we have to write IETS. Okay, so we can change it to IETS S dash. IETS is our alpha. So alpha S dash. Instead of alpha S dash, we can write like this. And what is our gamma? Here in this example, we can see that gamma means A. And what is the second production? A dash produces beta 1, beta 2, etc. up to beta n, right? Here we have beta 1 as epsilon and beta 2 as ES. So we can write it as S dash produces beta 1 bar beta 2. We have only two betas, so beta 1 bar beta 2. And beta 1 is epsilon and beta 2 is ES. So this is the final answer. This is a grammar which doesn't contain any left factor. Here you can check the first production. S produces IETS S dash bar A, right? So there are two terms and among those two terms there is nothing in common. I mean, those two terms doesn't start with the same factor. If they have something common in their right hand side, suppose this is also S dash, okay? So here S dash is common in its right hand side, but we won't consider that. We have to consider the common prefix, that means a common term in the left side of those terms. That is why we call it as left factor, not the right factor, it is the left factor, okay? So I'll just remove this S dash. And here in this second production, S dash produces epsilon bar ES. Usually we write epsilon at the end, right? So I'm just rearranging this, rearranging it to ES bar epsilon. Okay. Anyway, the meaning is same. Whether I write epsilon bar ES or ES bar epsilon, in both the cases, the meaning is just the same. Okay. So this is what we mean by left factor. And we will see some more examples. Let us consider A produces AB bar AC. Simple one, simple example. Okay. So here our static symbol is A. So we have to convert it to the form A produces alpha A dash bar gamma and A dash produces beta 1, beta 2, etc. up to beta n. Okay, so this is our form. We have to convert our production into this form. Okay. So we have to find the values of alpha, gamma, beta, beta 1, beta 2, etc. up to beta n. So what are those values? Here in this question, we can see that there are two terms, AB and AC. So what comes in common between AB and AC? Here we can see the term A. Both the terms start with the same factor A. So alpha is our A. And whatever comes after alpha, in each term, whatever comes after alpha is our beta. So here there are two terms. So there are two betas. So what is beta 1? Beta 1 means whatever comes after A, that is our beta. So this is our beta. So beta 1 is capital B. And what is beta 2? Beta 2 is in the second term, whatever comes after A is our beta 2. That is the variable C. So C is our beta 2. And what is gamma? Like I said before, gamma is optional. If there is gamma, we can substitute the value here. But if there is no gamma, remember, don't put epsilon here. Here in this question, we can see that there are only two terms and in those two terms, there is a common factor A. I mean the common prefix A. And there is no term here like gamma. So what can we do? We can just skip this gamma from here. Then our production will become A produces alpha A dash. There won't be any gamma here. Always remember, don't write it like this. Don't write it like bar epsilon. Since there is no gamma, don't write it like epsilon. Okay. So what will be our answer? Our final answer will be A produces alpha A dash. What is the value of alpha? Alpha is A. So A dash. And what's the value of A dash? A dash produces beta 1, beta 2, etc. Right? So here there are two betas. Beta 1 is B. So we can write it as B bar. What is beta 2? Beta 2 is C. So we can write it as C. So this is our final answer. Here you can check whether any more left factors are there. In the first production there is only one term. So there will be no left factor at all. And in the second production there are two terms, but both the terms starts with different variables. There is no common prefix among that. Okay, so we can say that there is no left factor in this final answer. Okay, now let's move on to our second example. S produces SAB bar SAC bar AB. So what is our alpha? Here you can see that there are actually three terms, right? There are three terms, and among the three terms, two terms have a common prefix. That is our SA. That is, you can see that in this first term, it starts with SA, and the second term, it also starts with SA. So you have to consider the most lengthiest common prefix. You can just consider alpha as S. S alone you can consider, or you can consider alpha as SA. Which one you should prefer? You have to take alpha equal to SA because it is the most lengthiest common prefix. Okay. So we know that alpha is SA. And what is our beta? In each term, whatever comes after alpha, that is our beta, right? So in this first term, SA is our alpha and then B will be our beta. So we can write beta 1 is capital B and what is beta 2? In the second term, after alpha, what comes after alpha? Capital C. So beta 2 means C. And is there any gamma here? Gamma means the term which does not start with our alpha. So here AB is our gamma. So we can write gamma is equal to AB. Now we can convert this production to the required form. That is S produces alpha S dash bar gamma. What is the value of alpha? It is SA. So alpha S dash bar gamma. What's the value of gamma? It's AB. AB. Now what is S dash? S dash produces beta 1, beta 2, etc. up to beta n. Here there are only two betas. So beta 1 is B and beta 2 is C. So this will be our final answer. Got it? So now let's move on to our third example. S produces A D bar AB. A produces A bar AB. B produces C D bar D C. So this is our question. And in this question, there are three productions, right? Till now, we have seen the grammars with only a single production. But here in this grammar, there are three productions. So what we have to do? We have to check whether the left factor is present in each of these productions. So let's consider the first production. S produces AD bar AB. Is there any common factor? Yes, right? The A is our common factor. So here we can say that alpha is equal to small letter A. Now what's the value of beta? There are two terms with common factor, right? So there will be beta 1 as well as beta 2. Beta 1 is, in this first production, beta 1 is AD. So beta 1 is equal to AD. And what is beta 2? Beta 2 means, in the second term, what is beta 2? Capital B. So B. Now we can write our solution. I'll write the solution here. Solution for question number 3 is, first production will be converted to S produces alpha S dash bar gamma and S dash produces beta 1 bar beta 2, right? But here we can see that there is only two terms. There is no gamma term. So we can just eliminate this gamma term from here. Always remember, don't put epsilon here instead of gamma. Okay. So what's the value of alpha? Alpha means A. So we can just replace alpha by small letter A. So our production becomes S produces A S dash and S dash produces beta 1 bar beta 2. What's the value of beta 1 and beta 2? Here it is. Beta 1 is capital A D. So A D. And what is the value of beta 2? Beta 2 means capital B. So we can write capital B. So the first production S produces AAD bar AB. This first production can be converted to these two productions, right? So the first production is finished. Now let's check if there is any left factor in the second production. Let's consider the second production. A produces A bar AB. Okay. So we have to rewrite the values of alpha and beta here. There are two terms. And what's the value of alpha? Here we can see that both terms start with the common prefix A. Right? So the value of alpha will be A. And what's the value of beta? What's beta 1 first? Beta 1 means in the first term, whatever comes after alpha is our beta. But here there is only alpha term. There is nothing that comes after alpha, right? So the beta 1 will be epsilon. And in the second term, we can say that beta 2 is small letter b, right? So we can convert the production, A production into A produces alpha A dash bar gamma. But here also there is no gamma term, so we can just avoid it. And A dash produces beta 1 bar beta 2. This is the general format. And now we have to substitute the value of alpha and beta here. Alpha is A itself. So we can change alpha to A And what's the value of beta 1 and beta 2? They are epsilon and small letter b. So we can just substitute the values epsilon and small letter b. Okay? Or you can just write it like a bar produces b bar epsilon. Okay? Anyway, both are correct. Generally, we write epsilon at the last. If you don't write that, then also it's correct. Okay, so we have finished our second production. Now let's move on to the third production. The third production is B produces CCD bar DDC. Is there any left factor in that production? No, right? The first term starts with C and the second term starts with D. There is nothing that comes as a common prefix in the third production. So we can say that there is no left factor in this third production, that is the B production, right? So we don't have to convert it to any other form. We can use this production as it is. And remember one thing which is very important. Don't forget to write this production to our final result. Since there is no left factor, we will generally forget to write that production in the final result. But always remember, you have to write the production even if it doesn't contain any left factor. So B produces CCD bar DDC. Now the third production is also finished. So this will be our final result. So in the question there were only 3 productions and we have converted those 3 productions into 5 productions. And this is our final solution. And here just check whether in any of these 5 productions there is a left factor. In the first production there is only one term, so there is no chance for any left factor. And in the second production there are 2 terms, but both the terms start with different variables. And in the third production there is only one term, so we can just ignore it. In the fourth production there are 2 terms, but both the terms doesn't contain any common prefix. And in finally the fifth production, in the question itself we know that there is no left factor in this B production, right? So now the solution is free from any left factors. Okay. So I hope you got a clarity about what is left factor and how we can eliminate left factor. We will be discussing some more examples which are little more complicated in my next video. Okay. So stay tuned. Thank you.